y-axis. So we've got our region we talked about on Tuesday, and we are making a solid with semicircles perpendicular to the y-axis. So immediately I know, since it's perpendicular to the y-axis, that again, I'm going to integrate dy. What is the area of a semicircle? So step one, find the area of your cross section. Okay, good so far. Because we're cutting perpendicular to the y-axis. So the little, and so I know this is probably more than you wanted to know, but the little widths of those semicircles, because we're finding volume, so we're taking the area of semicircle times the little bitty tiny width. That little bitty tiny width is a dy, a change in y, not a change in x this time. Does that make sense? Well, I need to figure out what the radius of one of those semicircles is. I know my volume will be 1/2 pi times the radius squared. I just need to figure out what the radius is. So what is the radius?
1/2.
Very good. First thing I need to do is go, okay, this function, it was square root of x, but I'm going to have to write it as y squared. We did this yesterday, but, or not yesterday, last time or so. This one was x squared, so we're going to have to write it as the square root of y. Remember, we chose the positive value on that because it is the right-hand piece of the square root of y. So I need to do right-hand curve minus left-hand curve. However, that's going to give me the full length of that semicircle, which is called a diameter. I don't need a diameter. I need a radius. So I do need half of that. So we're going to do y squared minus the square root of y divided by 2. Or you could have a half in front either way. It doesn't matter. Now, make sure that half is also squared. It is part of the radius. Questions about that one? You could if you called it a 1/4.
So 1/8 pi squared there then.
Yes. Did everyone hear Will's question and my answer? So can you move the 1/2 out in front? As long as you square it first, you can do that. Part D. Rectangles with a height equal to 4 times the base perpendicular to the x-axis. I'm going to draw this picture again really quick. Okay, so we are taking this and we are cutting perpendicular to x this time, making rectangles. Because I'm cutting perpendicular to x, what's my integral going to be? Yes. Mental note that. My area of a rectangle, well, normally a rectangle is length times width or base times height or however you want to write that. But this is a very special rectangle with a height equal to 4 times the base. So what would the area formula for that be? Which would be 4b squared. I need to know that for my formula. I need to get this formula down to the simplest form I can for setting up the integral purpose. Oh, I'll do this. So I got 4b squared. B, now I'm back to my x's again. So it would be top minus bottom, which is square root of x minus x squared. From 0 to 1. Don't forget also on the other one we need endpoints. But these endpoints, they're still 0 to 1. I kind of hate that I picked that particular problem to do your examples with. This 0 and 1 are the y values 0 and 1. This 0 and 1 are the x values 0 and 1. Make sure those are consistent with which way you're integrating. questions about that one? This finishes the lesson from Wednesday. These were the 2 examples we didn't get to. How is that going? That homework, how's it going? Good. It is due on Monday. Make sure you have that done. This is today's lesson. Every calculus book I've ever seen teaches this backwards, so the way I'm doing it, this is my first year doing it this way. Let me know how you think it goes. But I think it makes more sense to teach volume as a whole first and then go to volumes of revolution. So this is what we're learning today. This homework will be due on Tuesday. You will get it today. I hope you work on it, but it's not due until Tuesday. I'm also going to hand out your AP packet today that you can start working on if you want to. In my first hour, I told them they had to start working on it because I thought you were losing a work day. You are getting that work day back. So you may not have to. It still would be a great idea to get started on it, but not quite as essential as it would have been if you lost that work day. So, yes. We will probably put that work day. Yeah, we'll probably do Friday, Monday on yours too. What would happen if we took the graph of the square root of x and rotated it around the x-axis? What would it look like? Try to draw it. Visualize taking that graph and swinging it around the x-axis.
So it's like has.
I don't get what that means either.
You mean it's rotated in the third dimension too, or okay, like that? I see what you mean. So in the third dimension.
3 dimensions. Yes, coming in.
Are we finding the area of all flexes?
We're going to find a volume of that figure. Yes.
That's really so from the x-axis, each point on that circle is going to be its radius.
Look at you. I can just sit down. You got this one.
Beautiful, Will.
That's pretty cool.
All right. So it would create a solid, wouldn't it?
Yes.
Our goal for the day is to find a volume of solids like this. You can now see, probably with a little bit of information, how we could take a semicircle and revolve it around the x-axis and create a sphere. And probably use that to find the volume of a sphere formula. Y'all remember at the beginning of the year when some of you noticed that the volume of a sphere was the antiderivative of the circle area formula?
Yes.
Maybe this might have something to do with that. Anyway, so that's our goal for the day. Whenever we revolve around that axis, we create an object that has circle cross sections. Most books teach this first and then go into cross sections. I kind of like to teach cross sections first, gives you the overall picture, and then this is just a special case of cross sections where the cross section happens to be a circle. So we've got a circle cross section. We are adding up all of those circles. Whenever we revolve around the x-axis, we create circles that cut on the x-axis, perpendicular to the x-axis. So if we revolve around the x-axis, we get a dx for our volume. Notice it's the integral from a to b, pi r squared. Well, why would it be pi r squared? Area of circles. Nothing new, really. In fact, I kind of hope you find out that today's not a whole lot of new stuff except setting up the problems, being able to revolve something around an axis. If you rotate around the y-axis or some vertical line, then you get a dy. Your circles would then be perpendicular to the y-axis, creating a dy integral. So, in some ways, today is easier than yesterday because it's pi r squared. We're revolving, you're always going to get a circle. Cross section is always going to involve a circle. We're going to add up all those little bitty tiny circle areas and get a volume.
I hope so. It's in common work.
So I was looking at it, I thought.
What is it?
I was wondering if I was spelling axis right. It looked wrong for some reason.
Hey, it's possible that I spelled something wrong. But I don't know about axis.
I mean, I've been spelling axis.
Remember at the beginning of the year when I spelled outer wrong?
How'd you spell it?
O-U-T-T. I might have fixed it before because
I could probably.
maybe.
But now we know. We're gonna be fun.
Well, what's really bad about it is in my trick out class, it was still spelled the same way. I didn't fix it. And so I was like, when that came up, I'm like, oops. Because I didn't change the notes. Yeah. Did I spell something wrong there? Oh, oh yeah.
Yes, I remember that is.
I forgot about that.
That is pretty sure that I'm just using a different way to call it. Everyone needs to call it square.
It definitely sounds more fun than square root.
I just like use lines instead of natural law.
Okay, you don't have to write any of this down, but here is another visual. Yeah, we could. Okay. It is A to B up here, and then they called it C to D down here. They were just. That will still be from the intersection to intersection, maybe, but where you want the volume to stop it. Okay, so that's another picture of some other shape. That kind of looks like a vase. If you could write a function to model the side, which we will actually do that with a Hershey's Kiss later, we will find the volume of a Hershey's Kiss. Yeah.
All right.
Can we bring our own Hershey's Kiss?
For football game.
Because they have really big ones.
Yeah.
Just your ears.
Okay. There is another option. We could start with two graphs, and we could start with the area between those two graphs. If we were to do that, and I will show you that picture, it would make a solid with a hole in the middle. The cross section of that would be a washer, or a donut, or I don't know. Y'all know what a washer is? Okay.
Eating donut.
So the width of that would be that shape would be a washer. So there is a disc method, and then there's also a washer method.
So, in the washer method, there's two different graphs that rotate.
Or there's a gap for some reason.
So
We'll talk about that.
So in this one, you don't have like. I can't see where the other graph is.
So this one is made up of a horizontal line,
Okay, it's just a horizontal.
and then this top line, and they're both being rotated.
So the donut inside would stay the same size.
It would on this one.
But if you had a, okay, yeah, like one like that, it's gonna change size.
It would.
Okay, that makes sense.
How does it do this thing?
Maybe. Do what? Yes. Except this solid has a hole in it.
So
It's not a full solid, it's a solid with a hole in it. The cross section, Callie, if I kept this solid, the cross section, instead of being a solid circle, would be a circle with a hole in it.
yeah.
Now you tell me, how do you find the volume of a circle with a hole in it? Or I'm sorry, the area of a circle with a hole in it.
Big area and this little
You
area.
find the area of the big circle and you subtract the area of the little washer method. Now they factor the pi out, but the big radius squared minus the little radius squared. You don't find the area first, you're really going to do the big area squared minus the little area squared. One of the most common mistakes on this one is to subtract before they square. You have to do the big radius squared minus the little radius squared. Again, if you're revolving horizontally, you're going to get a dx. If you're revolving around some kind of vertical line, you're going to get a dy. Steps, and I'm going to give you a minute to write. I need to look and see what time we get out. Hey, John, will you look at that and see what time we get out? You might have to write that.
Oh, 1:25.
We got some time. Step 1. Draw the function and determine the region you're going to rotate. So step 1 is to do what we did yesterday and the day before, right? We got to draw that region first. We got to find endpoints, intersections, whatever it may be. We got to do all of that stuff. Step 2. If the region is rotated around the x-axis or any horizontal line, then you're going to use a dx. If it is rotated around the y-axis or any vertical line, you're going to do a dy.
So we do or don't have to write this?
Yeah, I would.
Well,
Now, if for some reason you would like to just print it later, that would be okay, but I'd want a copy of it.
can I just like take a picture of it so I can like look
Yeah.
at it?
That would be an appropriate use of the cell phone as long as it gets put right back up.
Don't post it to social media.
Do not post it. You would become the coolest person in the world if you posted this to social media.
Everyone knows that different calculus is like the number one.
It's exciting. The volume, like one of those pictures, would be so cool. Okay, here's step 4 is important. If when you rotate, there is a gap between the region and the axis of revolution, if there's any kind of gap for any reason, then you're going to have to use a washer. If there's no gaps, then you'll use a disc. You'll use a circle. If it's a disc problem, find R, use the disc method, you're done. If it's a washer problem, you got to identify capital R and lowercase r, big R and little r, big radius and small radius, and then use the washer formula, and then you're done. Well, y'all are writing. I'll pass out papers. If you happen to finish writing, go ahead and try to draw the region on that first problem. No one's going to grade it. There will be a lot of times that you'll need to draw the solid, just visualize it. We have passing those AP packets around. Yeah. Okay, example number 1. Find the volume of the solid created if the region bounded by the square root of x, y equals 0, where is y equals 0? Got the x-axis, the horizontal line, this one here. And the line x equals 3. So I have this region here. I'm going to take that region and revolve it around the x-axis. Is there a gap between the region and the x-axis? So this is a disc problem. because there's no gap between that region and the x-axis. So I'm going to take that and revolve it around the x-axis. What would each cross-section be? Circle. What is the radius of that circle? Square root of x, right? Just the height of the curve. Whatever x is, the square root of that's that radius. Notice I don't have to do a half on this one. Because it's not on top of the, sitting on top of the region, it's the revolution. So, I'm rotating around a horizontal, which means I am dx. Where am I integrating from and to? 0, 3. On this particular problem, I didn't need to find an intersection because it was just from 3. Pi r squared is the formula, and I said that r was the no. You see why? Where did you get that?
That's nice.
Yeah, because this intersects here. So that region is from 0. And does everyone see how I got the setup?
You would have like 3 equations. You would find to try to find the area that not including the first, second line.
Hold that up. Okay, I am going to save our time for setting up problems, but I would tell you this would be non-calculator because square root squared is just x. Pretty easy antiderivative. I'm not going to do antiderivatives just so that we get to see more examples. Discs and washers.
Yeah.
Did we get one? Yeah.
We got it. You got it.
Oh, you got one for me?
No, we got one.
Oh.
I got it.
Hey.
Hey, did everyone get an AP packet? Okay. Now, we want to find the volume of the solid created when we revolve the area between these two graphs, which would be this area here, around, first of all, the x-axis. We're actually going to revolve it around a bunch of things, but we're going to start with the x-axis. So, I messed that up. I said that. Does everyone see that?
Like a tower?
Yeah, I guess it could. Like a cone with the bottom cut off. So, does everyone see that? Let me help.
Some sort of work. Is it an open cone? Like is the bottom face?
This place is open, but this place is filled in. So that area becomes a solid shape. So
What is
which shape?
at the intersection? Is it just a circle?
Yeah, well, at this outside intersection, it's just a circle.
And what about the other side?
This inside intersection, you're going to have a big circle and a little circle. That one's a bad place because it's actually a place where they meet. But this one, you'll have a big green circle. And on the inside of that, you'll have a blue circle, which means you have a wash circle. So you have the filled in, that green this would be solid. And you've got the little blue circle that's not solid. So if you look at a cross section, you've got solid here and open. Now, of course, there are places on that where it's a full circle, but as soon as you identify this as a washer problem, now, I drew the picture, but how could I have identified it as a washer problem without drawing the whole picture? There's a gap between the x-axis and my region. Everyone see that gap? Anytime there's a gap, you're going to get a washer when you do a rotation. I am still rotating around the x-axis, so I am a dx. There is a gap, so I am using this formula. Identify what formula you're using first. Any questions so far? Now I need to find my radius. I'm not finding an area. I'm just finding a radius of two different circles. So if you could separate your brain out and look at these two as separate curves, you want the outer circle radius, like on the last problem, and then we want to do like the last problem again on the inner circle. We aren't doing any subtraction. We just want the radius of the outer circle and the inner circle.
So the outer circle will just be x plus 2, right?
Well, let's look. The outer circle is this green circle. Right? Everyone agree? Green circle? What is the radius of the green circle, the whole green circle? X plus 2. Does everyone agree? X plus 2 is the radius of the green circle. Any questions about how I know that? X plus 2 is the radius of the green circle.
And so the radius of the circle is just going to be x squared.
Let's look. So then my blue circle, what is my radius of my blue circle? X squared? So I have radius squared minus radius squared. Blue. Right. At 0, there is no blue circle because it's a solid piece at 0.
-1, there's 0.
There is at -1. Where am I integrating from and to? Where am I integrating from and to? -1. And what if you're unsure? Right?
Yep.
So -1 to 2. Any questions? Right. At 0, you have a solid because there's not a gap right there. Any questions about that one? Okay, the second one. We're revolving around the line y equals 5. Still horizontal, right? Very similar to the x-axis, still horizontal. So mental note that. So I'm taking this region and I'm revolving it around that line. So I get an inner circle here and an outer circle here. Okay, so this shape, I am not artistic, you'll have to forgive me. So I'm getting a bowl, essentially. Does everyone see the bowl? With kind of that inside shape with the rounded edges. Okay. Does everyone see it? This one's a tough one, or at least the first time you see it, so it won't be tough forever. outside radius. So I am pi 0 to, no, sorry, what did we say? -1 to 2. That's still the same because we're still dx. Outer radius. So let's look. Green circle. Now, I don't know anything about the curve up here, so I'm going to work with this piece down here. Would you agree that it would be 5 minus x squared? This distance. Top minus bottom. 5 minus x squared. That will give me the green circle. The blue circle will be 5 minus. So you will have to subtract top minus bottom to get some distances. Remember, not to get areas, but to get distances. I'm going to skip this one for now. We will come back and do it tomorrow, just so you can see a dy one really quick. Five minus parentheses x plus 2 squared. Say really quick, watch with me. I could also rotate this around the line x equals 7. Everyone see that?
Yeah.
So the outside radius and inside radius, right? We'll be talking about that blue distance and the red distance. I am doing dy this time. 0 to 4 this time. Is everyone okay with that? Why it's 0 to 4? This line is 7. So you would do 7 minus x, 7 minus y minus 2. And 7 minus the square root of y. We'll do more of these tomorrow or Monday. Remember, this is not due yet, but start working. Due yet, start looking at it. If you can completely stop work on the AP packet, oh, by the way, and if you don't want to write this down, this will be up here. These are the AP packet numbers you will need to do.
I'm so worried about this test. Like, I can't see this.
Well, and you also have to practice. Like, you're just, don't label yourself not good at it yet. You've got a lot of time to pick it up. This is one of those things that you'll probably go, you know, once you practice it.